All right. So if I want to write down the characteristic equation for this system, I have all the information that I need. देखून, I have the root locus here, but even if I don't have the root locus, I have the poles and zeros. I can write down the characteristic equation. Remember that my characteristic equation is 1 plus k gh equals to 0. Now, the poles and zeros that are described here are the poles and zeros of the open loop transfer function g and h. So, my characteristic equation would be 1 plus k into 0 at minus 3. So, the corresponding term will be s plus 3. Pole at s, and because of the origin, pole at the origin, because of this, s plus 0, then s plus 1, then s plus 2, then s plus 4 equals to 0. So I reconstructed the characteristic equation from the pole 0 map or the pole 0 information only. So this can be done. So now you can simplify for k, you can calculate for the angles if you want. But this, you should remember this technique, okay, how you can calculate or reconstruct the characteristic equation from the poles and zeros of the system. Now, I don't know which part belongs to H, which part belongs to G. I cannot separate G and H from the characteristic equation, but that doesn't matter for now. That's not important. Even if H was 1 and all of these belonged to G, no problem. Or even if H had one of the poles or zeros, or the 0, and the forward transfer function G had the rest of the parts, doesn't matter. So it really doesn't matter which part belongs to H and which part belongs to G. As long as you can reconstruct the characteristic equation, it's fine. Now, we learned 5 rules in the previous class. Rule number 0, or the starting point, was to find out the poles and zeros of the system. And then we learned 5 rules. Rule number 1 is to find the number of branches. The number of branches, I'm giving you a review. The number of branches will be equal to the highest power of s in either the numerator or the denominator of gh. Or you can also get the number of branches from the numbers of poles and zeros, whichever is the highest. That there are 4 poles and 1 zero, so the number of branches will be 4. You can get the number of branches in either of the ways. Rule number 2 is actually a matter of understanding that the root locus is symmetric about the real axis. The top half of the real axis is reflected in the bottom half. Okay. Rule number 3 is something that we need to calculate. This is actually the first step of the drawing part. So we find the real axis portions. For that, we travel from minus infinity to plus infinity, and we check the total number of poles and zeros on the real axis to our right. So if the number is odd, that portion will contain a root locus. If the number is even, it will not contain a portion of the root locus. So that's how we can draw the real axis segments. Now, rule number 4 and 5 are actually together. Rule number 4 lets us decide on the number of asymptotes required in the root locus drawing. The root locus always starts, each branch of the locus starts at a pole and ends at a 0. So if the number of poles and zeros are not equal, then you need asymptotes to compensate for the lack of, in this case, poles, for example, or lack of zeros. So in this case, we have 4 poles and 1 zero, so we need 3 asymptotes to cover for the 3 zeros, 3 absent zeros. So Rule number 4 is again a matter of understanding rather than something of calculation. Rule number 5 calculates the real axis intercepts of the asymptotes and the angle. The intercept point is always one, I mean single point. It'll be a single point. The angle will be different. So the angles, as I said in my last class, calculate only the number of angles required for the required to cover for the absence of zeros or poles. In our case, we need 3 zeros. We, if you remember, we call the asymptotes according to the textbook infinite zeros. So we need 3 angles. We have to use 3 consecutive numbers of n, either 0, 1, 2, 1, 2, 3, 150, 151, 152. Any number will do as long as they are consecutive. So we had our theta A, which is the angle. And finally, using these values, the asymptotes were drawn, and then I drew the root locus. The real axis portions were obtained from rule 3, and finally rule 5 helps us to draw the outgoing branches, the parabolic branches of the root locus. Now, as I said in my last class, we need to learn 3 more rules, rules 6, 7, and 8, which will be Motasim.
স্যার এখানে স্যার আমরা যে সিগমা এ বের করলাম -1.33 এবং স্যার থিটা এর মাধ্যমে স্যার আমরা 3টা ওই অ্যাসিম্পটটস বের করে নিয়েছি। সেই পর্যন্ত আমি ঠিকমতো বুঝতে পেরেছি। আমার একটা কনফিউশন হচ্ছে যে আমাদের যে ব্লু লাইনটা এঁকেছেন এখানে, যেটা স্যার 0 এবং -1 এর মাঝে আছে, এইটার পজিশনটা কিভাবে ডিটারমাইন করব সেটা বুঝতে পারিনি আমি।
ওইটার পজিশনটা আমি এখন আজকে দেখাবো, এখনো বলিনি।
জি, ঠিক আছে।
So as I was saying that we need 3 more rules. We call these rules 6, 7, and 8. Now, rule 6 is the finding of break away or break in point. I'll move a little bit to the right. Sorry. So let me get the focus back on. All right. Right. So break away or break in point. Now, what is a breakaway point or what is a break in point? Let's use a different color. Whenever you have two zeros or maybe 2 poles in the on the real axis, and you have a portion of the root locus in between the 2 poles or in between the 2 zeros. Okay. Then, only then, okay, as you increase the gain, the root locus will move out of the poles from the real axis at some point, and as you increase the gain, it will move in to the real axis again. Maybe it will travel the complex plane and then move in. So this is called a breakaway point. So it breaks away from the real axis, and the point to the right is called a break-in point. So we have to calculate where the point lies, either a break-in or a breakaway, or maybe they could simultaneously appear. We have to know whether this point is exactly in between the 2 pole positions or the 0 positions, or maybe biased towards the right or left. So we have to find out the exact location. So we'll learn how to do this. That is rule number 6. So to find out rule number 6, to find out the break-in and breakaway points, I'm sorry, all you have to do is rearrange the characteristic equation for k. So if I take 1, if I subtract 1 from both the sides and then divide by G and H, I'll have this one, right? Now from this you have to differentiate this and equate this to 0, and we'll get the solutions of this equation dk ds equals to 0. The solution of this equation will give us the breakaway and breaking point. Now why is this, how did this come by? Well, actually it's seen that if you look at the gain values between the two pole positions, you'll see that excuse me, the gain value at the breaking point is maximum. Okay. So the gain value at the breaking point becomes the maximum, and in a similar fashion the gain values in the breaking point is the minimum. So that's why, and dk ds equals to 0 just calculates the maxima or the minima of the function k. Okay, so k is a function of s in this case. So dk ds equals to 0 just finds the maxima or the minima. So let's do this before we learn the other rules. Let's do this for the transfer function that we have here. Okay, now if I rearrange this transfer function in terms of k, it will be k equals to, is it okay if I jump 2 steps, or do I need to do this in detail? So k into s plus 3 into s plus 1, s plus 2, s plus 4 is equals to -1, subtracting -1 from both the sides. Therefore, k is equals to minus s into s plus 1, s plus 2, s plus 4, and divided by s plus 3. This is our k. Now, therefore, dk ds equals to 0 implies you have to differentiate this. So if you remember u by v formula, you have to use that formula, v square v du minus u dv. Okay, so this implies s plus 3 whole square. This is our v, and our u is everything on top. ঠিক আছে? So s plus 3 into d ds of minus s, s plus 1, s plus 2, s plus 4. I'll move to the right a little bit. Minus u, and since u itself is negative, you can change the sign to positive, s, s plus 1, s plus 2, s plus 4 into d ds of s plus 3. This is equals to 0. Now, as you can understand that you can multiply both the sides by s plus 3 whole square, so the s plus 3 whole square at the bottom vanishes. ঠিক আছে? So I'm just going to erase this part because I'm out of space. ঠিক আছে? So multiplying both the sides by s plus 3 whole square, we get this equals to 0. এতটুকু পর্যন্ত সমস্যা আছে কারো?
No, sir.
All right, so if you differentiate s plus 3 in terms of with respect to s, you'll have 1, তাই না? So this will be equal
Yes,
to
sir.
1. Huh? So this will be equals to 1 just. And what about the left side? This is a third order transfer function, third order s polynomial of s. So let's do the calculations. So therefore s plus 3 into dds of, multiply everything, ঠিক আছে? And I can actually take this minus sign out if I want, ঠিক আছে? So I'm taking this minus sign out. So কত হবে? Can you tell me? So you can, if you want, you can do this in 2 steps. s plus 1, s plus multiply s plus 2 and 4, and then with s into s plus 1. Or you can do this in one step if you remember the formula. S plus a into s plus b into s plus c was equals to s cube plus s square into কত হবে? Do you remember? A plus b plus c plus s into ab plus bc plus ca plus abc. So this is the formula. Now you can, if you remember, you can use that formula directly. So in our case, this will be, see that you have a s at the front, so all the powers of s will be increased by 1. So if I multiply by 1, this will be s to the power 4, s to the power 3, this will be s square, and there will be an s here, simply. Okay? So let's write this down. S to the power 4 plus s cube into 4 plus 2 plus 1 is 7, right? So let me write this down. 7 s cube plus কত হয়? 2 ones are 2 plus 4 twos are 8. 8 plus 2 is 10 plus 4, 12 plus 8s. ঠিক আছে? Now you have to differentiate the whole thing. And at the right side we have just s into s plus 4, the polynomial itself. So 7s cube plus 12s square plus 8s into 1. This is equals to 0. So differentiating the whole thing and then multiplying by s plus 3 will result in something. And you can take care of the minus sign by bringing it to the right side of the equals to sign. So s to the power 4 plus 7s cube, sorry, s cube plus 12s square plus 8s will be equal to s plus 3 into differentiating the polynomial yields 4s cube plus 21s square plus 24s plus 8, right? So you have to multiply the right side, and both the sides will be a fourth order polynomial of s. Now you just need to compare the coefficients, right? Naki, where is k? I mean, what does it produce? Ultimately, can you multiply the right side? You'll see that 4 to the power s, s4 21s cube plus 24s square plus 8s, and then with 3, so 12s cube plus 63s square plus 324s are 72, right? 72s plus 24. This is the right side. All right. Now you can subtract one side from the other to get an equation solely of s. This implies 3s to the power 4 plus 21 plus 12 কত হয়? 21 plus 12 minus 7, so 26 plus
Yes, sir.
24 plus 63 minus 12 করেন, দেখবেন কত আসে, নিজেরাই বের করতে পারবেন আই গেস। বলেন তো পরেরটা কত হয়? 24 plus 63 minus 12,
75.
75. Very good. 75s square plus 8s cancel হয়ে যায় আসলে, 72s plus 24 equals to 0. Now all you need to do is factorize this. So you'll have to use your calculator possibly. You'll have to use your calculator and you can find 4 roots. Calculator use করেন তো একটু, আপনারা 4 রুটটা, এই 4টা রুট একটু বের করেন, আমাকে বলেন what are the 4 answers, what are the 4 results of this. 1, 2, 3 and 4. It's a fourth order polynomial, so you'll have 4 roots. So calculator ব্যবহার করে একটু আমাকে সলভ করে দেখান এটা। I will zoom out a little bit so that I can show you the root locus itself.
স্যার চারটা কমপ্লেক্স নাম্বার আসে।
চারটা কমপ্লেক্স নাম্বার যদি আসে, then we have made a mistake somewhere. আমি এই জন্যই root locus দেখাতে যাচ্ছিলাম. If you look at the root locus, you see that there is one, at least one, not at least one, actually exactly one breakaway point between 0 and -1. So I should have found one real solution for this polynomial where the solution would be between 0 and -1. Any other solution, real solution, can be discarded. ঠিক আছে? So can you check and tell me where we have made mistake? Did we make a mistake with the polynomial? Check it out, huh? এবং চেক করে একটু বলেন আমাকে, where do you think we have made mistake? So this is one of the methods actually. If you look at the textbook also mentions another method, but the calculation rigor, as you can understand, that this is a kind of a long rigorous calculation. If, for example, you have more poles, more zeros, the calculation becomes more tedious. Just a minute. So the other method does not reduce the complexity of calculation. So I'm going to just show you this method. Okay, you can learn and use the other method from the textbook, but as I said, it does not reduce the calculation rigor of the calculation in any way. So this one should be sufficient. Motasim.
স্যার যে লাইনটাতে লিখেছেন যে ডিডিএস অফ কে ইজ ইকুয়াল টু 0, স্যার ওইটাতে স্যার জি ও না স্যার ঠিক আছে স্যার, আমি স্যার একটু ভুল করেছিলাম।
It's okay. So so find out whether I have made a mistake anywhere. If not, then your solution, our solution to this expression, polynomial expression, should have contained a real number. Now why isn't it producing one? I mean, if the calculations are correct, then it should produce a real number, at least one solution which is between 0 and -1. All other solutions should be discarded. So you'll have to know the real axis portions of the root locus first. If you know that the real axis portion between 0 and -1 is present, for example, then you should understand that there should be a breakaway point between these two values, 0 and -1. So you should expect the solution of the dkds equals to 0 equation to contain at least one real number which is between 0 and -1. ঠিক আছে? So do the hand calculations after the class and just check whether we have made a mistake somewhere. Maybe there is a mistake somewhere. Ashraf.
স্যার এস কিউব টার্মটার সাথে কোএফিশিয়েন্ট 14 হওয়ার কথা।
14 হবে? Okay, maybe that's where we made a mistake. 14 হবে, s cube or s square?
স্যার x কিউব x স্কয়ার s স্কয়ারের সাথে স্যার
হ্যাঁ, ab plus bc plus ca, right?
হ্যাঁ
2 plus 8 10 plus 4 14, right? This is where we made a mistake. So this should be 14, everyone, huh? Thank you. So this should be 14. ab plus bc plus ca produces 14, not 12. ঠিক আছে? So the differentiation would be 28s, not 24 but 28s. Now it would possibly produce the correct results. And 3, so let's correct it here, 28. S square, and then 3 times 28 is কত 86 নাকি 84
স্যার 84
84, right? So let's correct this again. So now possibly it will produce the proper results. This will be 14, not 12. So using the new values, 3s to the power 4, 7s cube, the s cube terms remains the same. The s square term will be different. 28 plus 63 minus 14. So it will be 77, right? 77. ঠিক আছে না? And the s coefficient of s will also change. It will be 84. ঠিক আছে না? Excuse me. Now possibly you can excuse me, find the solutions again. Now possibly you will find the proper solution. Can you check?
স্যার দুইটা রিয়েল আসে, একটা ইমাজিনারি আসে।
হ্যাঁ, কত ভ্যালুগুলো একটু বলবেন?
স্যার আমাদের স্যার একটা আসে স্যার -0.43,
ওকে, আর
একটা আসে স্যার -1.61।
61, আচ্ছা, আর
স্যার বাকি দুটো স্যার ওই কমপ্লেক্স আসে, বলবো?
হ্যাঁ বলেন কত?
-3.3
-3.3 plus minus
প্লাস মাইনাস 0.68।
0.68. Thank you. So these are the four solutions of the polynomial. Now, excuse me, as I said, you have to first understand that your breakaway point or break-in point should be within a range. So in our case, the breakaway point resides between 0 and -1. So this is the breakaway point. The others can be discarded. So you have to say that the breakaway point is between 0 and -1. Therefore, we can use sigma because it's a real value. Sigma equals to -0.43. So instead of s, I'm using sigma. Okay, is the breakaway point. Okay. So the only problem with the calculation is that it's a bit long, and you know, you have to keep your concentration during the calculations. Otherwise, the results, the produced results might not be correct. Okay, so this is the breakaway point. So I hope this answers Motasim's question that you wanted to know where the point exactly was between 0 and -1. So this would be at -0.43. Okay. All right. So the rule number 7, the next rule. The next rule is for finding out the crossing points of the imaginary axis. Okay. So there will be 2 points in this root locus where the root locus will cross the imaginary axis, and this will be symmetrical, as you can understand. So this will be symmetrical. So you only need to find one. The top one, if you get the top one, you can just, because of symmetry, you can say that the other one is just negative. Okay? So we want to find out the imaginary axis crossing point. Okay, so I'm going to write down the name of the rule here. Imaginary axis crossing point. That's rule number 7. Imaginary axis crossing point. Now, as you can understand that these are not all root locus will cross the imaginary axis. For example, the root locus that's shown here in pink, this does not have any crossing point, imaginary axis crossing point. So you don't need to find the crossing point for this root locus. ঠিক আছে? So it depends on the type of root locus which you are handling. So for this system, for example, we will have an imaginary axis crossing point. Acha. The way to find out the imaginary axis crossing point is to use route table, simply. You have already encountered route table. So remember that, do you remember that we studied the concept of even poles? Now, transfer function had even poles if there was a zero row, and among the even poles were imaginary poles. So if for any value of gain k, you have a zero row in the route table, and if you have some imaginary poles because of the zero rows, then you can actually get the crossing points. So again, the starting point will be our characteristic equation 1 plus k gh equals to 0. And so for this system, I'll go to the top. For this system, we'll need to make a maybe cross multiplication. So we can start from the characteristic equation. Plus k into s plus 3 equals to 0. So we have to, of course, break down the number. We already did this, s to the power 4 plus what was the number 7, right? 7s cube plus 14s square plus 8s plus k into s plus 3k equals to 0. So if you just collect the terms, 14s square plus s into 8 plus k plus 3k equals to 0. Now let's make the route table. You've just learned this in Meet 2, so I don't think you've forgotten this. S to the power 4 will have a coefficient of 1, s to the power 2 will have s to the power 3 will have a coefficient of 7, and so 1, 14 and 3k, and this is 8 plus k. ঠিক আছে? So using these values, we can calculate a1, and this will be, what will be this value? 3k? Naki? So s to the power 1, this will be, let's call it a2, and this will be 0. Finally, s to the power 0, this will be 3k, 0, 0. So now we need a 0 row. Okay, so let's write it down. We need a 0 row. So the route table has a 0 row if বাকি আমি a1 a2 কিন্তু এখনো ক্যালকুলেট করিনি. Can you tell me for which conditions the route table shown here will have a 0 row? বলেন.
স্যার a2 0 হলে,
Very good. If a2 is equals to 0, any other conditions? মানে are there any other conditions?
স্যার অন্য কখনো
k এর ভ্যালুর উপর ডিপেন্ড করবে স্যার.
কি ডিপেন্ড করবে? Of course k এর ভ্যালুর উপর ডিপেন্ড করবে.
স্যার 0 রো হওয়াটা স্যার.
Of course k এর ভ্যালুর উপর ডিপেন্ড করবে, কিন্তু কন্ডিশনটা কি? k এর ভ্যালু কত? মানে a2 ক্যালকুলেট করিনি. once we calculate a2, if that is 0, that will be a function of k. ঠিক আছে, তার ভিতরে k থাকবে a2 এর ভিতরে. এখান থেকে I guess বুঝতে পারছেন. a1 a2 যদি ক্যালকুলেট করি, তার ভিতরে k থাকবে. So if a2 is equals to 0, you will find some condition, some values of k. ঠিক আছে, কিন্তু আমার প্রশ্নটা হচ্ছে যে আর কোনো কন্ডিশন আছে এখানে? মানে are there any other conditions? One is a2 is equals to 0, that will produce a 0 row. Anything else? What if a1 is equals to 0?
স্যার 0 তো আসার কথা না 0 কারণ k এর ভ্যালু 0 হতে পারে না যেহেতু.
Very good. k এর ভ্যালু 0 হতে পারে না for the same reason the last row cannot be 0. আমি এটি আসলে বুঝতে যাচ্ছিলাম যে আপনারা জানেন কিনা that gain cannot be 0, তাই না? If you remember that gain has to be always greater than 0. So that's why this is the only condition under which the route table will have a 0 row. So let's calculate a1 and a2. 1, 14, 7, 8 plus k divided by 7. So this will be কত? Minus 8 plus k minus 7 into 14, তাই না? So sign change হয়ে গেলে এরকম হয়ে যাবে. I'm jumping a step, right? So এটা হবে 14 minus 8 plus k divided by 7. উপরের মতো রাখতে পারেন, it's my choice that I am keeping this like this. এটা আমার ব্যাপার. Similarly A2, I have a lack of space. Let's calculate A2 to the left. ঠিক আছে? আচ্ছা, এই মিড-টুর খাতার ভেতরে আমি দেখলাম আপনারা যে A1 A2 ক্যালকুলেট করছেন, সবাই ক্যালকুলেশন মোটামুটি দেখিয়েছেন। হাউএভার মানে খুব ছড়ানো ছেটানো, একটু একটা সাইডে করলে খুব ভালো হয়। এরকম একটা মার্জিন দিয়ে একটা সাইডে যদি করেন তাহলে একটু ভালো হয়, গোছালো লাগে একটু দেখতে, তাহলে মনে হয় পুরোটাই রাফ ওয়ার্ক। আচ্ছা, A2 হচ্ছে এক্সকিউজ মি মাইনাস কত হবে, 777 A1, A1 থেকে A1 রাখছি আপাতত, because it's going to be very complex, divided by A1, right? So ultimately এটা দাঁড়াবে হচ্ছে গিয়ে again মাইনাস সাইনটা যদি আমি ভেতরে ঢুকিয়ে দিই এরকম হবে 8 plus k into A1 minus 21k divided by A1, তাই না? So ultimately 8 plus k minus 21k by A1. Of course, A1 is itself a complex, I mean quite complex figure, so you can use this one. A1 is 14 into 7, 14 into 7 minus 8 plus k divided by 7, so that 7 will go to the top. Eta hocche ki A2. Now if A2 is equals to 0, therefore 8 plus k minus the whole thing, ঠিক আছে, 14 into 7 minus 8 plus k and 7 into 21k should be equals to 0. ঠিক আছে? Again, you need to simplify this, so cross multiplication. All right, কত হবে, 98, right? Cross multiply by 14 into 7 minus 8 plus k. So you'll have 14 into 7, 8 plus k minus 8 plus k whole square minus 7 into 21k equals to 0. This will be the result. So 7 into 14 is 98, and minus 8 plus k whole square, you have to break it down, of course. Minus 8 plus k whole square, and 7 into 21 is 144, right? No, 147. 147. Now break down this 8 plus k whole square and then rearrange. So 8 plus k whole square, and you can of course multiply everything with a minus. So 8 square is 64 plus 16k plus k square, that's the breakdown of the square. Then minus 98 into 8 minus 98 into k plus 147k. I've multiplied everything with minus 1. Okay, so now simplify this and solve for k. You will get a value. Okay, Achha, this is the gain value for which the imaginary axis is being crossed. If your even poles have imaginary poles, even poles will contain imaginary poles. তো দেখেন তো আমাদের A2 যদি 0 row হয়, ঠিক আছে, let's mark it with a different color. If this is our 0 row, then yes, first we have to check whether the 0 is obtained for any positive value of k. ঠিক আছে, so that's why you have to solve this equation first to find out the value for which you have a 0 row. বোঝা গেছে কি? So you have to solve this equation. K square কত হয় বলেন তো? 16k minus 98 plus 147 কত হয়? ক্যালকুলেট করে আমাকে একটু বলেন।
65
65 165 না কত? শুধু 65?
Yes sir.
শুধু 65k, and then we have 64 and minus 98 into 8. এটা একটু ক্যালকুলেট করে বলেন কত হয়?
minus 720.
720
জি
sure
স্যার।
na acha ঠিক আছে 720 then can you find out the values of k again you can use your calculator no problem আপনার কথা কিছুই শোনা যায় না did you find out the value the solution for k if you find that the k value is positive হ্যাঁ কত
একটা আসে স্যার 9.65,
okay
আরেকটা আসে স্যার minus 74.65.
65 okay so you have one positive answer one positive solution it will do so for k equals to 9.65 your a2 will be 0 ঠিক আছে so therefore for k equals to 9.65 a2 will be 0 and the route table will have a 0 row all right now once you confirm that the 0 row occurs for a positive value now it's time to find out the crossing points now again let's mark this row as the 0 row because now we have confirmation that indeed for a positive value of k there will be a 0 row now do you remember that the even poles occurred because of the sign changes in the first column of these rows the row above the 0 row to the bottom of the table so the row above the 0 row is s square so you have to check whether a1 is negative or not remember these poles come in pairs so and there are only two even poles okay so either you'll have no sign change or if you have if you have no sign change then both the poles will be on the imaginary axis if you have one sign change then you'll have one pole on the right hand side another pole on the left hand side and if I get a1 negative then there will be a problem so let's check a1 shall we this is a1 a1 will be 14 minus 8 plus 9.65 that's the value of k divided by 7 can you check whether this is positive or not
Positive.
positive right so কত হয় ভ্যালুটা anyway
11.47.
11.47 thank you anyway a1 is positive so in the route table there are no sign changes all right so let's write down here it's a bit haphazard let's write it down here 0 row then after this we'll check the sign and there are no sign changes from s to the power 2 row to s to the power 0 therefore the two even poles are situated or positioned on the geometry axis this is our decision that we have indeed confirmed that the two poles will be on the imaginary axis now as I said now it's time to find out the points the points can be found out from if you remember how to treat a 0 row we have to form a polynomial so find the polynomial which is a1 s square plus 3k right a1 s square plus 3k of course we have to put the value of a1 and k So for k equals to 9.65, this was 11 point কত ছিল জানো মতসিম?
11.48.
40, thank you. Our 3k would be just multiply 9.65 with 3, you'll have this is 28 point something.
28.95.
95, no? Thank you. PS. This is our PS. Now, when we, you know, when we were dealing with the zero row, we used the polynomial to, you know, fill up the zero rows, values of zero row. In this case, in now, we don't have to go through that process. All we have to do is equate this with 0. Okay, and then find the solution of S. You'll see that S is imaginary. কত হবে দেখেন? 28.95 divided by 11.48, a square root. So the points are found from PS equals to 0. So this is a square root of 28.95 divided by 11.48. দেখেন, this will be imaginary.
1.59.
1.59, thank you. So this is our imaginary axis. Crossing point should be negative, তাই না? There should be, this should be negative in order for this to be imaginary. If you look at the equation, if you do a square root, it's a square root of a negative number, so it's imaginary. Automatically it becomes an imaginary number because of the -1 at front of minus 28.95. So this is your crossing point. So now we can say this is indeed 1.59, and the negative 1.59 will be at the other side. ঠিক আছে? So as you can see from the graph, I've made a error in scaling, right? If 1 is around here, my point is more towards maybe plus 2j, so it should be more maybe around here. So knowing these, just a minute, knowing these points, finding out these points can help us draw a more accurate graph or accurate root locus. That's all. All right. Okay, so the last point was the last rule, rule number 8, is to find out the, for example, acha, let's do this one. Let's see whether you can understand this. Let's say we have a pole zero plot of a system like this. So can you understand that the root locus will be like this? This is symmetric, and the poles will be the starting points of the root locus. There are 2 poles and 2 zeros, so the zeros will be the terminating points. We don't need asymptotes, so therefore the root locus will look something like this. Now the question is, how do I know that the root locus comes from below? Why didn't I draw this like this way? Let's draw the positive side only. How do I know that the root locus will stay below this horizontal green line, or whether it will come upwards, or maybe like this? How do I know that it won't terminate into the 0 like this? Well, that is the point of rule number 8. We want to find out the angle of arrival, or in case of a pole, the angle of departure. So angle of arrival, in case of a 0, the root locus arrives at the pole, at the 0, I'm sorry, angle of arrival of complex zeros, or 4 complex zeros, in fact, 4 complex zeros, or angle of departure for complex poles. Again, not all root locus, loci, root locus or root loci will have complex poles and complex zeros. Therefore, rule 8, you don't need to utilize rule 8 for all root locus, all kinds of root locus. For example, in this case, we don't have any complex poles or zeros. So therefore, you don't need rule 8 for this system. Rule 7, up to rule 7 would be sufficient. Again, for other systems, maybe you won't have to calculate rule, the crossing points, or even you don't have to utilize rule 6, breakaway points. So rules 1 to up to 5 should be, or I should say could be, used for most of the root locus plots. However, sometimes you see breakaway points, breaking points, you see or you encounter imaginary axis crossing points, you encounter complex poles or complex zeros. So for those systems, for those, to draw those loci, you have to utilize rules 6, 7, and 8. Now, I didn't discuss rule 8 yet. I'll discuss it in the next class. Okay. Any questions? No? Oh, okay.